We are doing congruent polygons, and we're going to talk a lot about identifying and using corresponding parts. Ooh, and I have your vocabulary packet. Okay. So this is saying, remember from last chapter, two geometric figures are congruent, can transform from one onto the other, if they can reflect and match up, or if they can translate, or if they can rotate. Some sort of rigid transformation will make them congruent. Because they are congruent, that means that all the corresponding sides and all the corresponding angles are congruent. So in this picture, when triangle DEF is the image of triangle ABC, after a rigid motion or a composition of rigid motions, you can write congruent statements for the corresponding angles and the corresponding sides. So right here we've got corresponding angles. Angle A corresponds to angle D. How do you know? Besides the fact that it's written there, how else do you know? Oh no. How do you know that angle A corresponds to angle D? Look at the picture. The congruence markings, but how do you know that A goes to D instead of A going to like F? When you look at their congruence markings, how do you know? I mean, what? There's only one. Right, there's only like one little arc in both of those. So those are the ones that correspond to each other. So they've got three of them that correspond to each other, marked congruent, and then the corresponding sides, the same thing. If you're looking at BC and EF, both of them have just like one little tick mark, where BA and ED have two tick marks and so on. So those are the ones that correspond to each other. If I don't do this now, I'm going to forget. A bunch of you are leaving for Butler Tech, so. There we go. Okay, and then when you write a congruent statement, and I've actually talked about this already, when you write a congruent statement for two polygons, we have to make sure that the corresponding vertices are in the same order. So in this picture, or this picture up here, angle A corresponds to angle D. So up here you see where A is, it's listed first. D is also listed first. We talked about that already. Some of you didn't quite pay attention to that on I think it was the quiz that I graded and handed back. I haven't graded the test yet, but on that quiz I remember people not paying attention to going in the same order. Over here, so if A corresponds to D over here, A is in the third spot and D is in the third spot. The ones that correspond to each other need to be in the same locations here. This here is just showing you if we, for this one to get to this one, if we translate ABC over, and then we rotate it, and then we reflect it, it'll be the same as the original. Or the new one, I should say. Okay, here's an example. A congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So let's do angles, and let's do sides. So I'm just going to pick one. I'll just pick the one that has one little arc in it. Angle L is congruent to what? Yell out. Let's go. Angle R. Thank you. Angle J is congruent to which angle? T. That means angle K is congruent to angle S. Now before I do the sides, could we write a congruent statement? Triangle, I'm just going to go in this order, LJK, yeah, is congruent to triangle, what will be the next three letters? If I do LJK, I'm going to have to go in the same order. RTS, right. All right, the sides would be JK is congruent to, now, because I went from J to K, I went from 2 arcs to 3 arcs. I need to do the same thing. I need to go from 2 arcs to 3 arcs. So side T to S. So I'm putting the corresponding ones in order. All right, how about if I do LJ? Alex, if I do LJ, what's the next one going to be? RT. And if, what's the other one I haven't done? KL. KL. So if I do from 3 arcs to 1 arc, I'm going to have to go from 3 arcs to 1 arc. Donovan, what segment would that be? Well, I just did K to L. So over here, what corresponds to K and what corresponds to L? S to... Does T have how many marks? R. Yeah. S to R. Because you got to think about how many marks it has. All right. That's a good example. Hello. There we go. In this diagram, this should have something in front of it. It doesn't. Okay, quadrilateral DEFG is congruent to quadrilateral SPQR. That is right now telling me which angles correspond to each other. Angle D corresponds to what angle? S. Stay here for a second. Just sit. All right. So what am I at next? E corresponds to what? P. F. Put 2 arcs in that one. F corresponds to Q. And then G would correspond to R. I'm not going to mark it because it's going crazy over here. Find the value of X. So I'm going to look over here. We need to find the value of X. Where's a place that, over here, where's something that has X in it? You guys have this on your own paper. You don't have to stare up here if you can't see it. It is on your own paper. I know, I love how you're all like, oh, I can't see it. John, do you see an X somewhere over here? Describe where X is. Okay, I mean, like, is it on an angle? Is it on a side?
Oh, yeah.
And which one? Angle Q. Okay. On angle Q, there's actually a Y and an X. And if we have 2 variables and only 1 equation, you can't solve for both variables. So is there somewhere else that only has 1 X? Cameron. It's not an angle, dear. Did you see the line what? From what to what? Yeah, so we say segment QR. Yes, segment QR has just the X in it. So segment Q to R corresponds to which segment over here? This one has 2 markings, and then R I didn't mark at all. So which one over here has 2 markings? And then which one did I not mark? F to G. So we have a length of 12 over there. Yep. So I'm going to set 2x minus 4 equals 12. Now we've got solving equations. When you guys get to Algebra 2, you will be glad that you had to solve so many equations now. Algebra 2 has a lot of solving, right, Avni? Right, where's Aaron? Oh, right, Aaron? You have a lot of solving in Algebra 2, right? Yeah. So it's good that we keep practicing that. So we got 2x equals 16, divide by 2, x equals 8. Now we have to find the value for y. So I'm going to go back to looking at angle Q that has a y in it, but it also has an x in it. What do you think I should probably do? I should probably plug in the x, and then what will Q equal? I'm sorry, correspond to. Angle Q is corresponding to what? Angle F. So I'm going to have it equal 68. So we'll have 6y plus 8 equals 68. Then I get 10. Oh, yes, sorry. All right, moving on. Think deeper. Can you tell, how can you tell that the triangles are congruent? Let's look at the sides first. We have PR congruent to, not PR, PT, sorry. Oh my gosh. My lead is like moving around and I keep writing bad because of it. PT congruent to RT. We've got ST congruent to QT. Aw, QT. And then we've got PS. Now I have to think here. P to S is starting. P is the one that's in between the 1 and the 3 marks. So then I'm going to have to go between the 1 and the 3 marks, which is R to Q. R to Q. In order for this figure to be congruent, we need all congruent sides and all congruent angles. Which angles are congruent? Huh? I didn't name any angles. Which angles are congruent? No, it doesn't. But you have learned ways of telling which angles are congruent by theorems and postulates we've done. So I ask again, I put this on a couple weekly reviews. Which angles are congruent? It wasn't said the exact same way I'm saying it, but the answers were on those weekly reviews. Which angles are the same? Some of you are leaving. Let's get this out. Which angles are the same? What? P and Q. Why?
Both in the vertical angle theorem or whatever. Like there's something with the congruent angle, whatever. I don't know the reason, but P and Q are.
Okay, what if I told you P does not correspond to Q?
Then P and R.
But why?
I don't know. Great question.
Okay, that's why we're doing this. We have to kind of think back. And this is a lot of the stuff that we're doing in this chapter now. Does anybody have a different? Or this, you are right. P and R are congruent, but I need to know why. Avneet, did you have a different one, or you know why P and Q? Or P and R? Right, but there's nothing marked, so there's got to be another reason why the angles are congruent, because they're not marked congruent. There's got to be something we've learned in here, the reason why those angles are congruent. I can't hear you. She got really quiet. I can't hear. What angles would be congruent, though? That is a thing. That is a thing, but not the angles you were talking about. She's saying vertical angles. What is she talking about? What do vertical angles look like? They have to do with an x. Do we have vertical angles in here somewhere? John, do you know which ones are vertical angles? Okay, I can't hear you, hon. QTR. Are you saying the second one?
Yeah.
I just couldn't hear you, hon. QTR, what corresponds to Q? S, TP. I just couldn't hear you. Okay, by vertical angles, congruence theorem. Okay, if they're congruent, if they're vertical angles, they are congruent. Got one down. There's something else in this picture that's supposed to be giving you a hint. You got some parallel markings, don't you? That's right. So what's that going to tell me? Maybe I should turn the page this way. If these are parallel lines, what is this? What's it called? Starts with a T. Transversal. And if we have a transversal that intersects two parallel lines, what kind of angles are these? Alternate interior angles. And we have a theorem that's like alternate interior angles theorem that says these are congruent. So what angles are there? Angle P and angle R. By alternate interior angles. Okay. And then we've got one more. Let's see what's left. We haven't done S and Q, so let's say it's going to be S and Q. But why? Turn it this way again. Why would S and Q be congruent? John? It is alternate interior angles again. They just have a different transversal. Alternate interior angles. Theorem. Alternate int angles. There you go. When the Butler Tech people, field trip people get called down, I do have a worksheet up here that you need to grab, but I'm going to keep going until you get called down. All right, there are properties of triangle congruence, and we've talked about these properties before with segments and with angles. We've got the reflexive property that says triangle ABC is congruent to triangle ABC. Exact same thing on both sides. We've got the symmetric that says if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. That's where we just like switch the stuff around the equal or. And then transitive, if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then ABC has to be congruent to JKL. That's transitive. This is the third angles theorem. If we know we have two triangles that are congruent already, and we have two angles in them congruent, you guys know what every single all the angles added up together in a triangle adds up to be? The sum is what? Sorry. Okay, the sum of the angles in a triangle is always 180 degrees. So if we know two of these are congruent, no matter what they are, if I subtract these angles from 180, I should get the exact same answer here. So these would have to be congruent by the third angles theorem. Should I say that again? If we already have two.
Please excuse the interruption. Sophomores that are going on the Butler Track field trip can now report to the...
Okay, so using the third item, we're going to find the measurement of angle BDC. This is the kind of stuff that you're going to be doing in this chapter, where we might have some things overlapping or sharing sides. There are two triangles here. There's actually more than two triangles here, but there are two triangles here. I'm going to separate them so you can see them. Nope, that doesn't look like it. So this is A, C, D. And from ACD, I know that A is 45 degrees and D is 30 degrees. Okay? And then I have the other triangle, which is CDB. C is marked with 2 arcs. B is marked with 1 arc. And we have to find angle BDC. BDC. We have to find this angle right here. So we're going to use the third angles theorem. If angle A and B are marked the same, and angle D here and angle C here are marked the same, what has to be true about big angle C here and big angle D here? What has to be true? They have to be the same. Now I don't have any measurements in the second triangle, but in the first triangle I have a 45 and a 30. Can I find C? What do they all three have to add up to be? 180. So if I take away the 45 and I take away the 30, what's left should be angle ACD. So it's like taking 75 away. So what's left? If you took away 75 from 180, 105, right? So then what's the measure of angle BDC? Ryan, what's the measure of angle BDC? BDC. It would be 105. That's right. Because these are 45. These are 30. Both of those are going to be 105. Good. Last one. You ready? You guys all ready? I bet you can fill out number 1. No, don't fill out number 1. I forgot. I'm doing this the way the book did it. It's probably not the way I would do it, but it already had the numbers, so I'm going to stay the way they did it just this one time. What do we normally write for, like, number 1? Given. Okay. I'm only going to write the sides that are given this time. Okay? We'll do the angles later. What sides are given congruent? No. Maybe I'll give you a hint. AD is congruent to what? Matthew. CV. Oh, John, you'll get candy or something. You've been answering a lot. Okay. One at a time, hon. Oh, you want to answer the next one? Oh, there you're getting up like, I want to do the next one. Don't skip me. All right, I'll call on Stephen this time. Stephen. In this first triangle on the left, I'm going to say CD. is congruent in what? AB. Very good. So that's given. Now our goal is to show that the triangles are congruent. To show that the triangles are congruent, we have to show all the sides and all the angles congruent. I have two sides already given congruent. What is the third side on the first triangle? I've done AD, I've done CD. What's the third side on this first triangle? David, do you know? AC. Now, what's the third side on this triangle? Jay, what's the third side on this triangle? Well, that one's marked, so that one I already wrote CB. I wrote it as CB, but BC already wrote.
You mean one with like 3 markings?
Well, there aren't any, but there's one that's not marked in this triangle.
Oh, AC. Oh, you're right,
Oh, see, this AC was in this triangle. There is a third side in this triangle I have not said yet. CA. That's right, Cameron. It's CA. Now, what do you know about side AC and CA? Why was that confusing? Because why? I'm asking something that's like obvious. It's the same side. So we use something over here for the reason. Well, it's not over here, but it's one of these three. For the reason that AC is congruent to CA, that says it's because it's exactly the same thing. What would be our reason that says it's exactly the same thing? What is it? Reflexive property. So far, we have all three sides congruent. Usually I mark, when it's like the same side, I mark it with like an S for same. Because how else do you mark that side congruent to itself? I don't know. Same. All right. Now let's talk about the angles. So there are given angles. We are, I'm going to start on the left side. We were given DAC is congruent to, then we have to go to the right side, and it has to be the one that has one arc. So it's going to be BCA. And then also, the one that has two arcs would be DCA is congruent to BAC. And why are those congruent? Why are those congruent? Why are those congruent? Oh, come on. Stephen, why are those congruent? So what do I write here? Same thing I marked for number 1. Given, yeah. That was told to you. It was marked, therefore it's given. So we have to prove the other two angles are congruent to each other. So the other two angles, do I need 3 letters to do this angle here? Do I need 3 letters for this one? So I'm just going to call it angle D, because there's only one angle D. It's congruent to angle B, but we need a reason. Aaron's going to tell me the reason. He's going to do it. Right, Aaron? I'm going to interrupt Aaron's thinking process just for a moment. You can keep thinking. But if I called on you to help Aaron, but not tell him the answer. If you could give him a hint, but not tell him the answer. Think about that. Sometimes when you're on the spot, you get nervous and then you can't think because I'm staring at you. Just because you raise your hand doesn't mean I will call on you. I promise I'm just not going to call on you random. But how many people think they could give them a hint? So that means nobody else in this room knows, except for one person. Jay, would you be willing to give them a hint? Well, no, it's not the same. They're definitely different areas. All right, I'm going to give you a hint.
Please excuse the interruption. This is the last call for any of the students that are going on the Butler Tech field trip today. Please come to the auxiliary gym at this time. Thank you.
It's somewhere on this page. The reason is somewhere on this page. Reasons are like definitions, things you can, properties, theorems, postulates. He knows. It's the third angle theorem because we already have two angles congruent. Therefore, the third angle has to be congruent. Thank you, Aaron. Third angles theorem. Now for our last step, we always put what we are trying to prove, which we should have proved it now. Triangle ACD congruent to triangle CAB. You don't even have to do much thought process about what order to put the letters in because they've already done it for you. The reason, if you could say it in your own words, I'll tell you what to write. But if you could say it in your own words, why are both of these triangles congruent now, David? Just in your own words, like, why are both of these triangles congruent? Oh, do you not think they're congruent?
I do.
Well, why? Why do you think? Okay. So you put a lot of trust in me, even though I make mistakes all the time.
I just don't know the reason.
Well, let's go back to the first page. You don't know the reason? Let's look at the first page. No, I'm looking for where I want you to look. Hold on.
I thought you were
Incongruent polygons. It's not a definition. I don't want you to say the actual thing. I want you to say, like, in your own words. Why would those two triangles be congruent? I gave you a hint. Not just that they're yeah. It's because the corresponding parts are congruent. So to show that two triangles are congruent, we show that all three sides and all three angles that correspond to each other are congruent. That's what you would write for the last step. Okay? I just have a really short 9-question worksheet for you. You got some 10 minutes to work on it now.